Hello and welcome to today's lesson on the equations of motion and kinetic energy. Our learning objectives are to apply the equation for kinetic energy and apply the equation that links initial velocity, final velocity, acceleration and distance travelled. Which do you think would have more kinetic energy? A small bullet moving at a very, very high velocity, or a large steamroller moving at a very slow velocity? To answer that question, we need to know which factors affect the kinetic energy of an object. Mass and velocity are the two factors that affect the kinetic energy of an object. Kinetic energy equals half times mass times velocity squared. This is the equation that links kinetic energy, mass and velocity. Don't forget when you're using this equation to take into account the squaring of velocity. In this example, we're going to be looking at a tennis ball. The tennis ball is moving at 36 meters per second and has a mass of 50 grams. The first step to solve this problem is to convert everything into standard units. So grams needs to be converted to kilograms, so its mass is 0.05 kilograms and its speed is 36 meters per second, so we don't need to do anything with that. And then we plug it into the equation, half times mass times velocity squared, giving us 32 joules. And I'd like you to try and calculate the kinetic energy associated with a 20-ton steamroller. A ton is 1,000 kilograms. Remember to change it into base units first. Pause the video while you calculate the answer. The answer would be 122,500 joules. If you got this answer, that's fantastic. If you didn't, the most common mistake is either forgetting to square the velocity or squaring all of half mass times velocity. Remember, it's only the velocity that's squared. For the next question, we'd like to find the kinetic energy associated with the bullet. Remember, you need to convert 4 grams into kilograms. Pause the video now while you calculate the answer. And the answer for the bullet would be 1,767 joules of kinetic energy. We're now going to be looking at an equation which relates to constant acceleration. Can you think of any situations which involve an object undergoing constant acceleration? Pause the video now if you want to give yourself a couple of minutes to think about it. One of the most common situations for constant acceleration is an object falling under its own weight. Here is the equation that we're going to use, and it is worth noting that you do get given this equation in the exam. The equation is final velocity squared minus initial velocity squared is equal to 2 times the acceleration times the displacement. And this is a constant acceleration equation which requires the acceleration to stay fixed. We're now going to go through this example of a ball being dropped a distance of 1.5 meters with an acceleration of 10 meters per second squared, and this is the acceleration due to gravity for all objects. Calculate the final velocity. Well, we know that the initial velocity is 0, the acceleration due to gravity is going to be 10 meters per second squared, and the distance that it's falling is 1.5 meters. Our next step is to rearrange the equation to get our unknown value on one side of the equation with all the other values on the other side. So here we have added u squared to both sides of the equation, giving us an equation v squared equals u squared plus 2as, where v squared is the final velocity squared, which is equal to u squared, which is 0, plus 2 times 10 times 1.5 for a total of 30. So v squared is equal to 30 v is the square root of 35.5. Find the final velocity of a car with an initial velocity of 30 meters per second and an acceleration of 2 meters per second squared when it's travelled 675 meters. Pause the video now while you work it out. You should have got a final value of 60 meters per second. Find the final velocity of a water bomb dropped from 5 meters. Take the acceleration due to gravity to be 10 meters per second squared. Remember, its initial velocity, if it's dropped, is going to be 0. Pause the video while you answer the question in your book. The answer would be 10 meters per second. Find the final velocity of a bike when its initial velocity is 4 meters per second and the deceleration is minus 2 meters per second squared after 3 meters. And the answer would be 2 meters per second. Well, that brings us to the end of today's lesson. I hope you found it useful, and thank you very much.